Hello, my name is Tejas Gupta.
And I'm Sid Srivastav, and in this video we are going to demonstrate the lab exercise of 2D composite transformations.
Yeah.
So
Here's our code.
this is the code. So I'll basically go ahead and run and then explain line by line
Side by side we will explain it
how
to you.
it's happening. So initially we enter the number of points, so I'll just take 4, and then I'm basically going to make a rectangle. Okay, so these are the options that we have. Okay, so this window will show the output. So let's just start. Okay, so here first we'll choose translation. Then we enter the translation matrix. Let's just say
Enters the vector, yeah.
let's say 150. Let's take it 200. We press enter. So this is the initial
rectangle, yeah, before translation.
This is the after translation.
Yeah.
It moved 150 in the x coordinate and 200 in the
y coordinate. Yes.
Then we apply rotation to this figure. Rotation angle, let's just take 90. And reference point is basically about which we have to bring the change. So our coordinates have changed. So initially it was 100, then we have added 150. So 150 is 250, so 350 will take for the x. For the y coordinates we had 200, basically 150 and 200. 200 and 150, 350. Okay, so we press enter. Okay, so this was our initial rectangle. So after we press enter, so it just got rotated 90 degrees, as you can see.
Yeah.
Okay, now we'll apply scaling.
Okay.
3.
Yeah. So now it asks for the scaling factor. Let's take it 2. And then the reference point, we'll take the same reference point as 350, 350. So this is before scaling, and now this is after scaling. So it just got bigger by a size of 2, like the x,
both x and y direction.
Both x and y direction just became double. And now for the last shearing part, the shear value, let's take it 4 and 4, and the reference point same, so that we get a clear distinction between the different types of transformation. Let's take it in x direction. No, let's take it in y, because our rectangle is horizontal. So this is before shearing, and this is after. Oh, because because our rectangle is in horizontal vertical direction only, so there is no shear in y. Let's take it.
Tap enter. 5 enter.
So now we will show you the coding side by side so that you can get a clear view. So let's minimize it, and here's the code. Yeah.
So basically we have taken this input of options. So for one is the translation. So we take the input for the translation vector tx and ty, and whatever is the value of tx and ty, we add it to the initial coordinates, all the coordinates, basically all the points that we have taken. 4 points we have taken. So we have taken the loop from 0 to n, which is 4. So we add all the points in the coordinates. the basically translation vector, and then before translation we print it, and on any input from keyboard we print the after translation whatever it is. Same way rotation angle, so we take the input of angle in degrees and then we convert it into radian.
Yeah.
And we take the input of reference point, which is basically about which the angle is to be rotated, the figure is to be rotated about which point. So basically this is the vector for changing the like bringing the change in angle of the figure. So initially, like on paper when we do it, like in the normal coordinate system, it's the x dash here, it should have been x cos theta minus y sin theta, and y is equal to x sin theta plus y cos theta. But since this has like different this system has different coordinate system, so for this x is equal to x cos theta plus y sin theta, and y is equal to y sin theta plus x sin theta plus y cos theta. So here again we print the line before rotation and after rotation.
Yeah. And now comes the scaling part. So in the scaling, we first enter the scaling factor in the reference point, and then we calculate the scaling. So here is the basic important part where we calculate the scaling. So here nothing, we multiply the x coordinate with the scaling factor, and this is for the y coordinate that we multiply with the scaling factor, and this is nothing but the reference coordinate. So we do this because we have to make the scaling about that reference point. So this helps us in getting the final figure about the reference point, 1 minus sx into rx. And so finally this is for the shear. Here we first enter the shear value and then the reference point, and then the direction in which the shear has to take place, and then we simply calculate the coordinate of the final shear and we print it. So this was our code for the final composite transformation, 2D transformation. So thank you.